Hello, my dear friends. Welcome to the class of 11th English Medium. The subject is Statistics, Chapter 2, Presentation of Data, brought to you by Vitan Sir. Now, today's tutorial is a small one. Today, I am just going to discuss three sums, which has a particular characteristic here, and we will see how they differ from our regular cumulative frequency sums. Illustration 9. Less than type cumulative frequency distribution of weight in kg of 50 persons is given in the following table. Okay. Now this is the table, and we have the weight of 50% given in a format less than upper boundary point. So this is the frequency distribution with less than type cumulative frequency already created. So this is the distribution which we get when we convert a regular frequency distribution into a less than type cumulative frequency distribution. What we need to do here is solve these three questions given as follows. The first one is, how many persons have weight less than 45 kg? Okay, now this is a less than type distribution. So less than 45 kg. So in less than upper boundary point, we just have to select 45, and we have to check the frequency in that in the front of 45, that is 30. So naturally the people with weight less than 45 kg are 30 people. That is what less than type means. Okay, so less than 30 kg are 0 people, less than 35 is 7 people, less than 40 is 15 people, less than 45 30, less than 50 is 38, less than 55 is 44, and so on. Second question, how many persons have weight between 50 kg and 65 kg? Okay, I will get back to that later. And last one is, obtain the original frequency distribution. Okay, that means when we used to convert our regular classes into less than type or more than type frequency distributions, now this less than type frequency distribution is to be converted into one of those classes. Okay, we will solve this one by one. From the given table, it is clear that 30% have weight less than 45 kg. So our answer for the first question is 30. Okay, second, number of persons having weight less than 65 kg are 49. Okay, we have two limits here, 50 kg and 65 kg. In the second question, we have to find the answer of number of people between 50 kg and 65 kg. So first of all, people less than 65 kg are 49. People less than 50 kg are 38. So when we find the difference between these two, we will get the people between 50 kg and the 65 kg. So the answer here is 11. Okay, so less than 65 kg are 49, less than 50 kg are 38, and the difference gives us the answer in between are 11. Now we will get back to the third one. Okay, we will draw the table first, write down the weight and the number of persons. Now, how we are going to do this? The first value here is 30. Okay, the less than upper boundary first point is 30, and the second boundary point is 35, and so on. So what I am going to do, I am going to write down the first class as 30 to 35. Okay, now just remember what we do when we convert a regular class into the less than type frequency. We take the first value, the very first value, as the first upper boundary point. Then we take the next value in the class as the second upper boundary point. Then the next class and next class and next class. So we divide the whole classes into singular values. We are going to do the reverse process. The first is 30 to 35. Next is 35 to 40. Next is 40 to 45. Then 45 to 50, 50 to 55, 55 to 60, 60 to 65, 65 to 70, up to the last point, and then the total. Okay, so the first thing was creating the classes from the given frequencies. What we did, we just copied down the values in a manner of a class. Okay, first was 30, then was 35, so first class 30 to 35. After 35 is 40, so 35 to 40. After 40 is 45 to 40 to 45. Similarly, we created all the required classes. Okay, next is calculating the frequency for each class. Now, just what we did in the second question, we have to decide what are the frequencies between 30 to 35. Okay, so people less than 35 is 7, people less than 30 is 0, so 7 minus 0, 7. Next, let us take another. People between 35 to 40. less than 40 is 15, less than 35 is 7. So 15 minus 7, 8. Once again, 40 to 45. People less than 45, 30. People less than 40, 15. Difference between 30 and 15, 15. Okay, once again, 45 to 50. People less than 50 is 38. People less than 45 is 30. So difference between 38 and 30 is 8. Similarly, difference between 44 and 38 is 6. Difference between 47 and 44 is 3. Difference between 49 and 47 is 2. And difference between 50 and 49 is 1. So what we need to do, we need to find the difference between the two values and just write them down accordingly. We will get the individual frequencies of all the classes, and when we make a total of all the frequencies, we will get the total 50. Okay, so what we did, we converted first of all the upper boundary points into classes, then we found the difference between the upper boundary points and got the frequencies for each and every classes. What we need to do is, whatever is the class, we need to make a difference between the frequencies of the values given in the class. If it is 45 to 50, find the frequency for 50, frequency for 45 and make a difference. You will get the frequency for the class. Same thing we can apply to more than type question also. You should remember that we have studied less than type cumulative frequency and more than type cumulative frequency. So next question refers to the more than type CF. Illustration 10. From the following more than type cumulative frequency, number 1, number of persons having age 40 or more, number of persons having age less than 40, and determine original frequency distribution. Okay, first one, the number of persons having age 40 or more. Now this is a more than type frequency distribution as it is. So 40 or more, so we will just check the value in front of the 40, that is 70. So people with age 40 or more are 70. Now second is a bit of a trick question. We have to determine the persons having age less than 40. Now here the value in front of 40 is more than 40, not less than 40. So what we are going to do, we are going to calculate that the total frequency is 100. How? The very first value, lower boundary point is 25, and in front of that the cumulative frequency is 100. Now we should remember that in more than type frequency, the very first frequency is the total of the whole data. In the less than type, the last frequency is the total of the whole data. The more than type, the first frequency is the total of the whole data. So first frequency here is 100. So total frequency is 100. And number of persons having age less than 40 is total number of persons minus number of persons having age 40 or more. How we are going to calculate this? So we are going to do a reverse process. We know that people with age 40 or more is 70 and total people are 100. So from total people we are going to deduct people with age more than 40, and that way we will get people with the age less than 40, and the answer here is 30. So 30 people have age less than 40. This is the reverse process. Okay, it's like I know that I have 15 rupees and I know that I have given 3 rupees to someone else. So now I want to find how much rupees I am left with. So 15 minus 3 is 12. So I know the total frequency is 100. I know that 70 people are older than 40. If I find the difference, I will know that 30 people are younger than 40. Okay, so this is the simple logic. Now we will move forward to calculating the original frequency distribution. First of all, the table, the title, age and number of persons. Okay, now just like what we did in the previous sum, I am going to follow the same thing for creating classes. The first lower boundary point here is 25. The second lower boundary point here is 30. So first class will be 25 to 30. Next class will be 30 to 35. Similarly 35 to 40. I am just following the lower boundary points here. I am not doing anything from my own. These lower boundary points are given as it is and I am just converting them into classes. Okay, so for 50, 55, 55 to 60, 60 to 65, 65 to 70, up from the beginning to the end and the total. Okay, we are going to follow the same thing here. The frequencies for the 25 and 30 are 196, and I am just going to find the difference between the two. So 100 minus 96 will give me 4. Similarly, for the class 30 to 35, the frequency for 30 is 96 and frequency for 35 is 87. So 96 minus 87 will give me 9. Then 87 minus 70 will give me 17. Then 70 minus 45 will give me 25. 45 minus 25 will give me 20. And then 11, 8, 5 and 1. Okay, so what I am doing here, I am again following the same thing, that I am just making a difference of the frequencies in front of the class boundary points. For example, if it is 50 to 55, then the frequency for 50 is 25 and frequency for 55 is 14. So the difference between the two is 11. So the frequency from 50 to 55 is 11, and the total frequency, as you can see here, is 100. Okay, so I hope you guys are getting this properly. Next is illustration 12. Information regarding the number of errors per page in a book of 500 pages is as under. Find the inclusive frequency distribution from it. Okay, we have the mid values of all the classes, and we also have number of pages. Okay, this is not a cumulative frequency method, this is converting mid values into a regular classes. But the catch here is that we don't need exclusive class, we need inclusive classes. Okay, first of all, we know that the all mid values have the difference 2 common. As you can see here, the difference is 2 common in all of these mid values. That means the class length of the class which we will be creating is 2. Now you should remember that to find the lower limit of the first class, the formula here is mid value of the first class minus half of the class length. Now first class is 0.5. As I told you, the class length is 2 and the half of it will make it 0.5 minus 1, and I will get the answer negative 0.5. I will find the upper limit of the first class. The mid value plus half of the class length will be the formula here. So 0.5 plus 1 upon 2 into 2, that is 0.5 plus 1, 1.5. Okay, so that is the upper limit of the first class. Now what we are going to do is, the first class is negative 0.5 to 1.5, and we will follow the same formula for each of the mid values, and we will get a table like this. Okay, I am following the same formula for each of the mid values here. The first class is negative 0.5 to 1.5, the second class is 1.5 to 3.5, the third class is 3.5 to 5.5, fourth class is 5.5 to 7.5, 7.5 to 9.5. Now the problem with this is that this is an exclusive frequency distribution. Okay, this is just exclusive, this is not inclusive. Exclusive means the upper limit and the lower limit of the next class are same. For example, the first class is 0.5 to 1.5 and the next class starts from 1.5. So 1.5 is common in both. Then 3.5 and 3.5 is common in the two classes. So I don't want that. I want to make it an inclusive distribution, that nothing should be common. If you remember, when we converted inclusive distribution into exclusive distribution, we used to deduct 0.5 and add 0.5. We used to deduct 0.5 from the beginning and add 0.5 at the end. Okay, so what we are going to do right now is we are going to reverse the process. We will add 0.5 into lower limit and deduct 0.5 from the upper limit. Okay, I will repeat it once again. We will add 0.5 in the lower limit and deduct 0.5 from the upper limit to get an inclusive class. So that means first class negative 0.5 plus 0.5 will be 0 and 1.5 minus 0.5 will be 1. Then 1.5 to 3.5, add, deduct 2 and 3. Again 3.5 to 5.5, add 0.5, deduct 0.5 to 4 and 5. And the table will look something like Thus, what I am doing here, I am adding 0.5 in the beginning and I am subtracting 0.5 in the end. What I am doing, adding 0.5 in the beginning and subtracting 0.5 in the end for all the classes. That means now these classes are inclusive. With this, I end my today's tutorial. I hope you guys get it properly. If you have any doubts, just review this tutorial here. I will give you some sums afterwards for the practice of this exact same method. Till then, stay tuned and see you soon.